Hello everyone, my name is Anissa and today I'll be focusing on potassium trichloroeta-2 platinate 2. So the way I went about figuring out this coordination complex, I focused on the cation metal, which in this case is potassium, because we know that the cations are named first, followed by an anion ending with 8. So in this given complex, the cation metal is potassium and the anion metal is platinate. The symbol eta indicates hapticity, which indicates the coordination of a ligand to a metal center. So in this case, the superscript 2 implies the coordination of the ligand to the complex metal through two contiguous atoms. We also know that there are 4 ligands attached to platinum, which is ethylene and chlorine. The prefix tri indicates that there are 3 chlorine ligands attached to platinum, and platinum oxidation state is 2. So that is why it's potassium trichloroeta-2 ethylene platinate 2. So here in the slide, I included the molecular formula and the structure. So if you were just going to name the coordination complex based on just the formula, then you would know that the cation is potassium, and platinum, which is platinate, is the anion, and you would start with potassium trichloroeta-2 ethylene platinate with an oxidation state of 2, and here is the structure. So a little history regarding this coordination complex. Potassium trichloroeta-2 ethylene platinate 2 is also known as xysalt. The yellow crystals of xysalt was first characterized in 1827 as the first organometallic compound and olefin pi complex to be isolated in pure form. This was done by William Christopher Zeiss. He thought of the structure of his salt as a product of addition of platinum 2 chloride to ethylene. He reported this ethylene complex as an inflammable platinum chloride, which was prepared from platinum chloride and ethanol. So due to the discovery, scientists would analyze this compound, which would only lead them to question the bonding. Because during this time, no one could fully come up with an explanation of its bonding that agreed with its molecular formula. It took more than 120 years to have a better understanding of its bonding, which required the invention of a completely new theory, which is known as the Dewar-Chatt-Duncanson theory of bonding, that explains the type of chemical bonding between an unsaturated ligand and a metal forming a pi complex. So on this side, I am mentioning the intermolecular force of this coordination complex. So as shown in the figure A, the crystal structure is essentially ionic, and the complex ion trichloroethylene platinate ion cannot be considered independently. They are arranged in infinite double layers with ethylene groups on both surfaces and held together by 3 main types of interaction. There are columns of alternate potassium ions and triangle of chlorine atoms parallel to the c-axis. There are chains of hydrogen bonds which are parallel to the c-axis, so we have hydroxyl and hydrogen and chlorine, and then these 2 chains are cross-linked with the coordinate bonds with the complex ions, and by the ionic interaction can change of oxygen and potassium, which are parallel to the b-axis and approximately perpendicular to the other 2 chains. So the Zeiss-Salt interaction between layers consists only of van der Waals forces between the ethylene groups, hydrogen bonds between water molecules, and chloride ions. In crystals, usually have a distance between 3.05 to 3.2 angstrom, where here the distance of water and chlorine distance is 2.97 angstrom, and which are very close to the tetrahedral value, which provide good evidence for the existence of a strong hydrogen bond.